now going to look at combustion reactions. And we're going to look at two different types. The first one's going to be a combustion reaction, which is going to be a complete combustion. The second one will be an incomplete combustion reaction, which leads to different products. So we also have to include physical states with this. So the first thing we need to do is write down what is pentane. Now pentane, remember, that means 5 carbons. And it starts with the 5 carbons. Now please remember the formula for the anes, all right? We're looking at our hydrocarbons. It's going to be CnH to the 2n plus 2. So in this case, since we have 5 carbons, we're going to have 2 times 5 is 10 plus 2, 12 hydrogens. And when we have the combustion of pentane, that means we're going to combine it with oxygen. And we want to see what that yields. Remember, when we have complete combustion, what we're going to get out is CO2 plus H2O. Now let's look at the states of these that we're going to get out. First of all, pentane. All right, when we look at our hydrocarbons, methane up to butane, up to C4, what we're going to have there, those are going to be gases. All right, but from pentane up to decane, what happens is as soon as the chains get a little longer, they kind of get intertwined. So they're no longer gases at room temperature. Pentane is the start of the hydrocarbons that are liquids. All right, so we either have gases, anything under pentane, but from pentane on up, they're liquids. Oxygen, that's a gas. Check the periodic table. Carbon dioxide, a nice molecular. This will also be a gas. And since this is done, and it's a warm reaction, hot reaction, we're going to have the H2O in the form of gas as well. So those will be our states. Next thing we need to do, balance them. So we're going to have carbon, hydrogen, and oxygen. And over here, we're going to have carbon, hydrogens, and oxygens again. Remember, when you get to combustion, these tend to pose some challenging numbers for us. So let's go ahead and start with this and see what we get. First of all, we have 1, 2, 3, 4, 5 carbons on this side. I have 12 hydrogens. And start with 2 oxygens. Please remember to leave the oxygen for the end, because that's the one thing you can change where it doesn't affect anything else. That will help you solve this. On the reactant, or on the product side, I should say, I start with 1 carbon, 2 hydrogens, and a total of 3 oxygens. All right? Yeah, we know that we're going to have to deal with the odd-even problem that we have with the oxygens on the other side. But let's first go ahead and attack the carbons. Let's put a 5 as a coefficient in front. That will give us 5 carbons on this side. It also changes the oxygen. That gives me 10 plus 1. That takes me up to 11 oxygens. But that's perfectly fine. We know we can deal with the oxygens at the very end. Now hydrogens, they're not quite there yet either. We have, on the reactant side, we have 12. On the product side, we have 2. So let's go ahead and put a 6 in there. And that gives us now 12 hydrogens on the product side, but it also increases the number of oxygens. So my total now is 5 times 2 with the carbon dioxide. That gives me 10, plus 6 for the water. That brings me up to 16. 16 total oxygens. That's nice, because that's a nice even number. So at this point here, my carbons are the same, my hydrogens are the same. On my reactant side, I don't have enough oxygens. I need a total of 16 for that side. So I need an 8 on this. So that gives me a total of 16. And that, in fact, does balance, and that would be your final answer. So remember, complete combustion results in carbon dioxide and water, both of them in gaseous forms. Pentane, you have to know how to write that formula. So now let's go to the next problem. Next problem says write the combustion reaction for the hydrocarbon when it's in complete combustion. First thing, let's go ahead and figure out what is propane. Okay, propane, C3, figure out the hydrogens, 2n plus 2, 8. Now propane, as we just talked about, this is actually, since it's C3, anything C4 or below, this will end up being a gas at room temperature. Then, since it's going to be combustion, you're going to add that with oxygen, and oxygen's a gas. And this will yield, then, with incomplete combustion. Remember when we talked about this in class, this will result in carbon, which is a solid, plus carbon monoxide, which is a gas. And finally, it will also give us water as a gas. Notice H2O, gaseous H2O, is the same in both, but that's it. Other than that, instead of being carbon dioxide, which is the first case, you're going to have carbon and carbon monoxide in this case. That's our equation with the states. So now we have to go ahead and balance the equation. Draw my line at the yield. Carbon, hydrogen, oxygen on this side. Carbon, hydrogen, oxygen on this side. Here I have 3 carbons, 1, 2, 3. Hydrogens, I have 8. Oxygens, I start with 2. On this side, we better do conservation of mass because I only have 1 carbon there, plus a carbon from the carbon monoxide. That gives me 2. Oxygens, I start with 2. And hydrogens, I start with 2. As you can see, not very balanced so far. I need a total of 3 carbons. I'm going to leave those for the end. All right. First thing I'm going to try to balance here is actually going to be the hydrogens. All right. So I see I have a carbon on the product side, which is by itself, and oxygen on the reactant side, which is by itself. Leave those for the end. Balance the one that's shown up not by itself on both sides, and that's going to be the hydrogens. So in this case, if I want 8 hydrogens on the reactant side, I have to put a 4 in front of the water. That'll now give me 8. It's good for the hydrogens, but it also gave me a total of 3 more oxygens. So on this side, it gives me 5. So now I have 5 oxygens on that side and only 2 on the other side. Now, the next step here, though, would be, wouldn't it be nice if I could get an even number of oxygens on the reactant side? So I'm going to go ahead and put a 2 in front of there. That gives me another oxygen. That takes me up to, not there, the wrong one. I need to add this to the oxygens. So that gives me another oxygen there. That gives me what? 2 plus 4. That takes me up to 6 oxygens, which is where I knew I wanted to go. All right. So now I have 6 oxygens, and my hydrogens are still at 8. My carbons are now at 3. Notice how it kind of matches. And that looks pretty good. The only thing that's not matching here are the oxygens yet. I need just to have 6 total in the reactant side. How do I get 6? I put a 3 in front of that oxygen. Gives me a total of 6. So this one is in fact balanced now. It gives the states. You have the balanced chemical equation. This one's done.